All right, guys, day 3 is a special type of factoring called difference of squares. This is my favorite type of factoring. Reason being, it is the easiest and the fastest way to factor. But I'm also going to throw out there right now that this is typically the one students mess up the most. I really don't know why. I think you just, the day I teach it, you're like, oh my gosh, this is so easy. Then you kind of like forget about it. And then when it shows up again, you're like, I don't know what to do with that. Okay, but this should be the easiest factoring that you guys ever do. Right? So if I just give you a problem that looks like that, how is that different from every problem we've been factoring so far? It's only got 2. Normally, how many do we have? We have 3, right? We had ax squared, bx, and then c, right? X squared, x number. We talked about that yesterday. They were always in that form. This one's not in that form. So what part of it's missing? The x. Okay, so let's rewrite it so that it's in the form that we like. Right? We like the ax squared plus bx. If I put 0x, did I change anything? No. 0x means it's not there. And then there's my c term. So now it's in the form that I like. My x squared, my x, my number. Everything we factor is in that form. Okay. So let's just kind of attack it like we've attacked all of our problems so far. Let's find out. So is there a GCF? We'll kind of start there. Always the first thing we look for. No, nothing goes into all of them. Can we divide them all by 0?
No, you can't divide it.
Thank you. You're right, I can't divide anything by 0.
Divide everything by, no, not even. So you can divide everything by 1. That doesn't work as good as common factor for obvious reasons.
Yeah, we can always divide by 1, but does it ever change anything? Angel and Angelina, phones, up here. Guys, your phone should not be in your hands anywhere near you. All right, so no GCF, so that means we jump right to our 2 sets of parentheses. My last one is negative, so what are my signs? Good, 1 plus, 1 minus. All right, options for A. Options for C. All right. And remember, we're trying to get a 0 in the middle. What should we use for A? 4 and 4 and 5 and 5 makes sense, right? So if I do 4x and 4x, and if I use 5 and 5, this gives me 20x. Outside gives me negative 20x, which is 0x. I canceled out. I got that to go away. Now, let's kind of look again at what we got going on here. So, all right, I chose the option that the numbers were the same because what was I trying to get to happen in the middle? I was trying to get to 0. I wanted it to cancel out, right? Okay, well, what do you notice about A and C? What types of numbers are those? They're squares. They're perfect squares. All right. Okay, so my numbers are perfect squares. You think that's a requirement? It is. I need them to be perfect squares so that I have a factor that are exactly the same, exactly the same. So I needed that to happen. All right, what about signs? What do my signs have to be in order to get them to cancel? Opposite. One's got to be plus, one's got to be a minus, which means this last term has to be negative. Okay. We just described difference of squares. So kind of our factoring flow chart, right? GCF is always first. This is what we've been working on. Now we have 2 terms. Technically, I could put the 0x in the middle. I could make it 3 terms. But what's happening is these are perfect squares. Both numbers are perfect squares. And it has a minus sign, which is what you guys just told me. Both numbers are perfect squares, right? So we had 4 and 4, 5 and 5. Minus sign allowed it to be 1 plus, 1 minus. And technically, what were those numbers? They were the square roots of each of them, right? If we come back to this, square root of 16 is 4. Square root of 25 is 5. Do you see why these should be like the fastest things you've ever factored? If you guys know your perfect squares, these should be really quick. These are my favorite. All right. My board's being weird today. All right, so again, remember, the last one's negative. That's what we wanted. We wanted the opposite signs to be in there. All right, so it's called difference of squares. This is a lovely textbook part of it. But let's look down here. Which of these are considered difference of squares? What do you think, Ben? Dylan? The third one? He thinks this one's difference of squares? So the requirement was that it was two terms. Okay. The outside numbers, they had to be perfect squares. Okay. What was the third requirement? It had to be negative. It's actually not because it's not negative. All right. Yeah.
12, second one.
This one?
Yeah.
Okay. So it's two terms.
Yeah.
It's got my minus sign. 4 is a perfect square.
Yeah.
But is there a GCF there?
Yeah.
Okay. What if I take out the GCF of 4? Is that helping? That becomes 3x squared minus 1. Is 3 a perfect square? No. Can't do that one. Is this one? What number's here? What's the square root of 1? Okay. What's the square root of 25? Ooh, so that one will factor. So if we go to factor this, last one is negative, so we know one's plus, one's minus. What's the square root of x squared? X. And the square root of 25 is 5. Again, if you want to check them, inside gives you 5x, outside gives me negative 5x, which is 0. That canceled out that middle term. So this one is a perfect square. Those are difference of squares. What about the last one? Is that a difference of squares? Two terms, minus sign, are both numbers perfect squares? So yeah.
I feel like only one perfect square is that.
One being a perfect square, remind me when we get through the end of the notes, I want to show you an example of a problem, okay? Just remind me, because I want to show it to you. Ones, yeah, they kind of keep going. So the square root of 1 is 1, and that continues on. So your job, Quinn, remind me at the end to show you something, okay, about ones. All right, so last one's negative. What are your signs? My square root of 36x squared. 6x. Square root of 1. It's 1. All right, so part of your homework tonight is you're going to have, different problems on there. And some of them you'll have to take GCFs out, okay? Sometimes when you look at it, you're like, that's not difference of squares. But once you take a GCF out, you're like, oh, yeah, there they are, okay? So make sure you're always doing that. But then some of them, all you can do is take out a GCF, and then that's it, okay? Now, like, technically, I put an X over that because that's not a difference of squares. But if I would just give this to you and say factor, you'd be like, okay, I'll take out a 4, have 3x squared minus 1, and that would be as far as that factors. Because since that's not a perfect square, I can't go any further. But I have students all the time, they look at that and they're like, that doesn't factor. I'm like, yeah, it does. You factored out a 4, but that's as far as it factors, okay? If it doesn't have a GCF, like this one, that one's not factorable. There's nothing there's no GCF, it's not a difference of squares, there's nothing I can do to that, okay? All right, let's get some more practice with these. X squared minus 49. Is there a GCF? No. Is it a difference of squares? Yeah. Right? Because you have two terms, a minus sign, and they are both perfect squares. What are your signs? Plus and a minus, because the last one is negative. Square root of x squared, 1x, and square root of 49. Factored. Did you see why these are my favorite? Look how fast those were. Love them. How about the next one? 16x squared minus 1. Is there a GCF? Yes? No. Yeah, nothing GCF. Is it a difference of squares? Yes. What are your signs? Square root of 16x squared, 4x, and 4x. Square root of 1. All right. What do we know about factoring? My final answer, I should be able to do what with it? I should be able to multiply it to get back to the beginning, right? We've talked about that for factoring the whole way. When you factor, you can always check them by multiplying them to get back to the beginning. Every year, someone in here is going to do it. I'm going to give you a problem like this, and you're like, oh yeah, I can factor that, and you'll do this. And call it done. People do it all the time. Can I ever take this to get back to that? No.
I think a little bit.
You need both parts, okay? That way you can multiply them to come back. Angel? Okay, let's talk about that. She said 4x plus 1 squared. What does the square imply? It implies we have two of those, right? So it'd be 4x plus 1 and 4x plus 1. Is that the same as this? No, because if I check this, inside gives me 4x, outside gives me 4x, and together they would make 8x. They won't cancel because the signs aren't opposite. Okay. No, I'm glad you asked, though, because that's always a common answer. People want to do that. Yeah.
So, wow. I have a good question. I don't remember what it is.
This problem right here?
Yes.
Should we? All right, we'll go through it, and you let me know if a question comes back. All right. Is there a GCF? No. Okay. Is it a difference of squares? And I know that because there's two terms, a minus sign, and 25 and 36 are perfect squares. So what are your signs? Plus and minus. Otherwise, they'll never cancel out. Square root of 25x squared. So that goes in the first part. And the square root of 36. And we are done.
Okay. So,
Yes.
my question was, is the order of the plus and minus matter, the matter of the minus become right?
If I multiply this back together, do I still get what I started with?
Yes.
Right? So if I would check, that's negative 30x,
Order doesn't matter.
positive 30x. Right. It's just like if I had 2 times 3 or 3 times 2, does it change the answer I get? Still get 6, so it doesn't matter. Good question. You guys are asking really good questions today. 50x squared minus 18. Is there a GCF? Corey, what is it? Good, it's 2. A lot of students are like, they look at that and they're like, oh, I can't do it. Those aren't perfect squares. But the first thing we always look for is a GCF, which in this case, I can take out a 2. So what are we left with? Good? All right, so again, when you take out your GCF, take it out, tell me what you have left, then try to go ahead and go further. Is this now a difference of squares? Yeah. Now, if I took out the 2 and they weren't perfect squares, what would I do? You would just stop there, circle your answer, and call it good. Okay? But these are, so I will keep going. Don't lose your baby brother. What are your signs? All right, what's the square root of 25x squared? And the square root of 9. Good. All right, why don't you guys try the next 2 on your own? What's the first thing we always look for when we're factoring? GCF. What goes into 64 and 100? Take out a 4. So you're going to be left with 16x squared minus 25. Is that a difference of squares? Yeah, these are both perfect squares. So you're going to have 4x plus 5 and 4x minus 5. Now let's talk about the majority of you, what you had for an answer. Majority of you looked at this and you're like, oh yeah, those are both perfect squares. So you went 8x plus 10 and 8x minus 10. That's great, but look at this. Do you still have a GCF sitting in here?
Yes.
Do you have a GCF sitting in here? Yeah. You can take a 2 from here and take a 2 from here, and 2 times 2 is the 4 you should have taken out to begin with. Okay? So anytime you factor and you're like, wait a minute, that worked, but I have GCF still sitting in here? Did you have a GCF sitting in the beginning? And we did. Okay? So just be aware of that. Yes, it does factor without taking it out. However, that's not simplified. Just like you would never leave 5 over 10, right? You would simplify to 1/2. You got to simplify here. How do we do on the next one? Was that one factorable, Angel? Good. Take out a 3. And then does that factor further? Mm-hmm. Very good. A couple of you wrote not factorable because what do we look for first? GCF. GCF. Quinn?
Oh, I get it.
All right, last 3. 121x squared minus 144. Whew, those are big numbers. Is there a GCF? Are they perfect squares the way they sit? Yeah. Now, if you're looking at that and you're like, oh, they're perfect squares, but I'm not sure if there's a GCF like we had in that last one, factor it. Okay? Let's just do it. We recognize they're perfect squares, but we're not sure if there's a GCF. One's plus, one's minus. What's the square root of 121x squared? 11x. Square root of 144. Is there a GCF sitting in here? No. That means there wasn't one to begin with either.
Attention students and staff.
All right. How about x squared plus 100? Is there a GCF? No? How's that one factor? Uh-oh. I heard x plus 10, x minus 10, and I heard it can't. Ben?
It's 10 for 100 and then 1 for the x.
Hold on, we're debating this out still. You're right. The square root of 100 is 10. Square root of x squared is x. Yeah. There's a plus sign. Yeah, because there's a plus sign here, this one is not factorable. In order for it to have 1 plus 1 minus, that sign has to be a minus in there. So that one is not factorable. All right, what about the next one? I got the minus sign on that one. What do you mean? 4 is a perfect square. Good. It's got the minus, which I'm happy about. 4x squared, that one's perfect, but 75 is not. This is not factorable.
Wait, I completely missed what happened. Wait.
All right. Quinn, were you supposed to remind me of something?
Yes.
Yes. Let me show you something. We talked about the ones. If I gave you x to the 64th minus 1, and I asked you to factor that, is that a difference of squares? Yes or no? Is it 2 terms? Is there a minus sign? Or are they both perfect squares? I have a 1, and what's the number in front of the x? A 1. Okay, they're perfect squares, right? All right, so one's plus, one's minus. We know the square root here. What goes for the x part? It's not x to the 8th. Nope. Be x to the 32nd. Because think about when you multiply, what do you do with exponents? You add them. Okay, but hold on. I told you I want to show you this problem for a reason. This one still has a minus sign. And 2 terms. One's a perfect square. Is x to the 32nd? Is that a perfect square? Does this one break down further? Is this a difference of squares? See the plus sign? This one's not because there's a plus sign, right? So this one would stay the same. This one would break down further. 1 plus, 1 minus, square root of 1, still 1. X to the 32nd this time would break down to what and what? X to the 16th. Okay, well, this one has a plus, this one has a plus, so I know those don't go any further. This one has the two terms, minus sign, and these are both perfect squares. One's plus, one's minus. X to the 8th, X to the 8th, 1.
Break some more.
It keeps going. I'm going to get lazy and stop rewriting this for the time being. All right, this one will break down again to plus X to the 4th, 1 and 1. Does that one keep going? Yeah. Does it keep going?
Yes.
1 plus, 1 minus, X. Finally. Does this one keep going? No, because I have just a plain X now. I can't keep breaking that down. So your final answer is all of that. That is completely factored now. Isn't that glorious? Come on, that's kind of beautiful. But look at my exponents, 32, 16, 8, 4, 2, 1. The ones that still had a minus sign were difference of squares, so they just kept going and kept going and kept going. The ones that had a plus sign, they're not difference of squares because there's a plus sign. Yay, I love that problem. It's fun.